Hi, my name's Caroline Wadsworth. I'm the Water Innovation Hub Manager based at Sheffield as part of the 2065 research programme. We're here today at Exeter University on the campus and we're looking around some of their rainwater harvesting management systems. We have a growing population with increased rainfalls, and that means we need better, smarter ways of dealing with our water and managing it in the future. So here at 2065, we're working to bridge the gap between academia and industry. And in this research theme, the team are focusing on accessing rainwater within cities, whilst also seeking to manage rainwater discharges using green infrastructure and source control systems.
My name's David Butler. I'm Professor of Water Engineering here at the University of Exeter and leader of this research theme. The problem is in our cities that we're either getting too much rainfall or we're getting too little rainfall. And part of our research work, or the main focus of our research work, is to look at ways to deal with that. How can we find technologies that will both solve the problem of too much rainfall, flooding, too little rainfall, drought?
My name is Virginia Stovin. I'm a reader in urban drainage at the University of Sheffield. My role within the 2065 project is that I co-lead a theme which is all about joining up how we think about stormwater management and rainwater harvesting. In particular, we're looking at how we can make better use of sustainable drainage systems, which are often referred to as SUDs, and rainwater harvesting systems.
My role in the team is to obtain and analyse data around the dual-purpose functionality of rainwater management systems. Over the last 12 months we've been working with SciWem to analyse data from 500 respondees to a questionnaire that they provided called the Big SUD Survey. And we've recently just published the findings of this research.
So within my research I'm particularly interested in the green infrastructure or the vegetated SUDs, so something like a green roof. How does it actually act when we get a rainfall event? How much of that rainfall ends up being retained in the roof? How much of it maybe gets delayed before it flows on to a sewer or a watercourse? And we spent a lot of time, we've got quite a lot of knowledge now about how these individual devices perform, to the extent that we can now tell the engineers how to model them within their drainage network models, and we can start to think about how we might use these devices as part of a broader catchment initiative to better manage flooding and stormwater.
Dual-purpose rainwater management systems are a way of capturing rainwater runoff so that the water can be reused within the buildings. That enables us to flush our toilets and irrigate our green spaces. Like we're standing here outside the forum on the University of Exeter campus. This green space here is irrigated from the rainwater captured on the roofs up there. But the water is also used to flush all of the toilets in the building. So it's important that we work towards integrating these resources within our cities so that in the year 2065 we'll have systems that work in our cities that capture rainwater and reduce downstream flooding consequences. By collaborating with the water service providers across the UK, working within the 2065 project, we'll be able to access more data than we'd be able to get working on our own in the lab. We're really looking to get real-world data on the dual-purpose functionality of SUD systems to demonstrate that they can be used for non-potable water reuse at the same time as attenuating these large storms.
What we're hoping to do with this research theme is very much continue the overall work of 2065. We're going to continue with our collaboration with practicing engineers, with planners, with policymakers. And what we really want to do with this theme and the project as a whole is to make a difference to society.